All right, I think we'll go ahead and get started. Thank you and hello. Thanks for joining us for this session in our Enabling Canadian Innovation virtual conference. We're joined today by Nick Mitchell, one of our SOLIDWORKS account managers here in the GTA, and Talal Asfar, our electrical and electronics specialist on the CAD Micro technical team. Before we get things started, there are just a couple of quick housekeeping items to mention. This session is just one of 14 sessions taking place this week as part of our virtual launch. If you haven't already done so, you can still register for any of the remaining breakout sessions by visiting our website, cadmicro.com, and checking out our online calendar. All right, without further ado, I will pass things over to Nick to get us started.
Thanks so much, Jess. Thanks for that introduction. Guys, we're just going to go over the agenda quite quickly today. It's a relatively simple agenda. We're going to work through this introduction. Then we're going to promptly move over into SolidWorks Electrical. Talal is going to give us an overview of what that solution is. Then we're going to spend some time in the SolidWorks Electrical design environment, going over the user interface, working through a couple of workflows before introducing you to the new features and enhancements for 2021. After that, we're going to have a Q&A session before promptly moving into our SolidWorks PCB demonstration. Again, Talal is just going to introduce you to what that solution is. We're going to spend some time inside of that design environment, working through the user interface and some of the workflows before introducing you to the features and enhancements of 2021, leaving time for a Q&A session after that. Okay. Of all the SolidWorks products, I personally say that these two are probably my favorite, SolidWorks Electrical and SolidWorks PCB. Simply because they're easy to use, they're powerful, they're intuitive, and ultimately they integrate seamlessly, really, with the rest of the SolidWorks ecosystem, right? For example, mechanical design validation, data management. That being said, I do think that these products need just a little bit more visibility and attention in comparison to some of the other tools in the product lineup, in that we need to educate our customers as to what the solution actually is and what the benefits are. And that's what we hope to do on this presentation today. I'd imagine that most of you on the call today are either working with, electrical schematics or electronic schematics and PCB layouts, and want to understand how these specific tools differ in comparison to what you guys are probably using today, and ultimately how they integrate with SolidWorks. Specifically in regards to electrical design, if you guys aren't using SolidWorks Electrical already, then most of you are probably using either a non-dedicated schematic tool like AutoCAD 2D, Visio, DraftSight. A lot of you might actually be using AutoCAD Electrical, and some of you are probably using some higher end tools like ePlan, for instance. The good news here is that, if some of you are using non-dedicated tools, or if you're using, highly complicated, robust tools, that you'll find some middle ground with SolidWorks Electrical. When you start to understand that, we have raw sort of engineering and design power and functionality, and we truly have an automated process for your reports and documentation generation on the back end. What we've heard actually from our customers over the last couple of years, Talal, just move to the next slide there, please. Over the last couple of years, Talal and I have actually had the pleasure of speaking with a number of different EEs across many, many different industries. And they've said a couple of things to us, a few things actually, right? First is that they're probably using a 2D drafting tool, and their schematic projects are simply becoming more and more complex, right? And they're looking to bring a more intelligent schematic tool in-house. Some of the people we talk to are longtime AutoCAD electrical users, and the seasoned AutoCAD electrical users understand that they're really simple and quite frankly ignorant ways to break the intelligence of that tool. And really the fallout there is that they can't trust the output 100%, right? So despite the intelligence, so to speak, they still have to audit their work on the back end, right? And they just basically learned how to deal with that. And lastly, for the really high-end tools, the human resource and support aspect leaves a lot to be desired, right? There's a lot lacking there. They purchased the tool some time ago because they were looking for that power and functionality, and they typically have, a legacy employee that understands how to run that tool particularly well, but they have a hard time onboarding their new employees. They have a hard time training them, and the closest support system is in Quebec or somewhere in Europe, for instance. So, I guess in our world, in the software world, seeing is believing. And on paper, a lot of you might think that SolidWorks Electrical is actually comparable to some of the solutions on the market today, but the devil's in the details, right? The workflow details. So, going back to what I mentioned before, if any of this resonates, then I think you'll find that SolidWorks Electrical is actually a solution worth its due diligence. And, with that said, I'm going to pass the mic over to Talal, and we're going to get this demonstration underway. Okay, Talal, off to you, man.
Thank you very much, Nick. Yes, so this is the basic outline of my talk. As you can see in here, I'll do a basic overview of SolidWorks Electrical. Obviously, it's a huge software. There are lots of features in there. I cannot cover every and each single thing, but I'll try to give you a basic overview. But definitely, if you are interested, we can do a complete demo for you later on. We'd love to do so. The two topics I will focus on is the SQL-based automation. That's a very good feature in SolidWorks Electrical, which is lacking in a few other solutions. And we just want to show you a quick demo for that. And then definitely what's new for 2021 version, most of that capabilities are in the routing, the 3D routing features. And I'll show you some of that, and then we'll take some question and answers for you. Okay, so what's the basic electrical documentation process or design process? Okay, so, well, first you are gonna draw your schematics, right? You're gonna put your symbols in, connect the wires, number the wires, everything else. And then you're gonna move on to the next part, which is the documents. Those will include bill of materials. Maybe you need wires and cable list for all the components you might need from tool list and so on, right? And then you finally have to go back and do a complete audit because you need to check that the bill of materials and wire cables and everything does relate to the drawing you have made. Now, what happens is some people are using a different software for the draw part, but they might be using Excel or some other software for the bill of materials and all that. And that requires this third step of auditing. Now, what happens in SolidWorks Electrical is we have combined all these things into one software, right? So you can definitely do your design in SolidWorks Electrical. It's much easier and much faster. And then we go on to the next part, which is this. And that is the SolidWorks Electrical completely automates the other two steps, which is the bill of material generation or report generation, and actually kind of eliminates the audit part of it because the software is taking care of it for you, right? So that is the difference between SolidWorks Electrical and the other software is the automation capability. Now, how does it happen? Like, how does it do so? Well, let's see an example. For example, what do you need to do if you need to change a part? This is a simple schematic drawing of 3 motor circuit. And let's say we just wanted to change one part, just change this relay, right? Sounds simple, but it's not. If you go into the detail, and all electrical engineers will agree with me, it gets more cumbersome. Like, for example, you need to change the power cabling, right? You need to change the control wiring and check everything. Then you have to move on to your bill of material, maybe make changes there. Then the terminal diagram, symbol attributes, and a lot of stuff. So before you know it, it has combined into like 40, 45, maybe 50 items just to change one thing. And there's no spell check available for that. This all needs to be done by you. You can make a mistake in so many numbers and stuff. It will be good to have a software which is, taking care of it for you so that you can have a peace of mind. So that's where SolidWorks Electrical comes in. It has an SQL database running behind the software. Actually, there's not even a save button in our software. It is capturing every and each single click for you. It is capturing and storing all the information. So for example, it will keep a track of all the single wires you used. It has a cables manager. You can assign manufactured cables to it. It is controlling every and each single terminal connection. It is keeping a track of all the symbols, which are appearing in many of those drawings, all of them, where they are, how they are connected, which manufacturer parts are assigned. And then comes to the second part of this list, this to, from list, terminal list diagrams. These are all automated then. If you are keeping a track of all the things in the upper part, right, all the drawings, then the second part becomes automated. You just click a button and it happens. So let me show you very briefly what I mean by that. Okay, so in here, this is a schematic. This is a project right here. A schematic project with some symbols, 3 motors and wirings. You have circuit breakers, fuses. And you can have all these 14 drawings in this, But what we basically made in this project were just two drawings, this control drawing and this multi-line schematic. And everything else is automated in here. So what happens is the rest of the 12 documents were made by the software. What I mean by that is you can go into here and you can generate reports, right? And some of the reports are ready to go, like bill of materials here, list of wires, and there are lots of them available, custom made. And you can customize all of them later on if you want to do so, right? So this is the list of all the reports you can generate. And once you have selected, you're just gonna click this generate drawing button and it's gonna bring it. And here is my bill of materials. So it's all made automatically for me, right? And then, for example, list of wires. So what's going on? What's going on is very simple. Let me do a little demo for you. For example, let's say this is the power drawing we were having, right? Each of this symbol has also a manufacturer part associated, which is the actual part you're going to purchase from the manufacturer, and we can assign those manufacturer parts. For example, this 3-phase motor is from Leroy Summer, right? It's a 4-kilowatt motor, etc. Now the symbols have some intelligence in SolidWorks Electrical. It has only 4 terminals, 3 windings, and the protection wire. If you want to assign a part which is wrong to it, this software is going to warn you that this is not the part you want. So let's open this blank drawing, for example, here. What I can do is from my any previous design, and all the electrical engineers do it all the time, we reuse our design, right? I want to bring in this fuse. So I'm just gonna say copy, and I'll pick this part, and I'll bring it to this, and I'll just say paste. Okay, sorry. Let's see here, and copy, and paste. And this is gonna bring in all the information for me. Of course, I placed it in a little bit wrong space. So delete that, and paste, and here, there you go. So it brought in the information, which was the manufacturer part, etc., directly from the other thing. I can even take the complete entire circuit. For example, this whole motor circuit. I can highlight it. I can say copy with insertion point, and I can drag in here. And when I paste it, it brings it all the information. It is bringing in all the wires, all the components, even this cable, this motor, and the manufacturer part, okay? And if I want to number my wires, very simple thing, I'll just go here and I'll say renumber my wires, okay? And that is going to take care of the numbering of the wires. What is happening is behind the scene, there is this list of components, and it is taking care for me all the components I'm putting on my drawings. And in each of this component, it is telling me which drawings it exists on. For example, this one is drawing 3 of this project. This is on drawing number 7. So this is the SQL database working behind the scenes for us. Right now, for example, I brought in here, it brought in this motor. That motor is on this drawing number 4. If I go to it, it will zoom into this drawing in here. And within the drawing, you can copy and paste as well, or you can turn it into a macro. For example, I can take this drawing. This is motor number 1. So if I say copy with insertion point here, and then say Control V, and do it one more time, and that's it. So it numbered the first motor M1, second one M2, third one M3. All my information is here. It included cable number 7 here, cable number 8 here, cable number 9. It generated all of it itself. It brought in the 3 circuit breakers. It just started calling them Q1, Q2, Q3. I don't have to go one by one and chase every and each component. I have peace of mind that the software is going to take care for me. So this is the kind of automation we are talking about, which becomes available to us when we are doing with SolidWorks Electrical, because there's an SQL database taking care of all this for you. And once you are done with the drawings, then the next step is a special type of drawing, which is 2D electrical cabinet design, right? So you can also do that. It's also very important for most of our manufacturers and customers to assign this. In this, you have to see if all the parts are going to fit in a cabinet, right? It has to be actual size. So these are rails and ducts for the wiring. And I don't need to generate all the parts again, because when I'm going to create this drawing, since I already have this component list created for me by the software, it's going to bring in all the relevant components. I'm just going to pick and place them in here. And going one step further, and we will focus on that part a little bit, is the 3D assembly part. For example, our software connects with SolidWorks Mechanical 3D CAD. What Nick was mentioning, that there is an integration between the two software. And what you can do is create 3D parts, SolidWorks assembly in it. And here we have created that. And let me show you what we mean by that. Just a second. And if I open, so this is a 3D electrical assembly. So it's a mechanical part which has all the wirings. It's going through this clip. And the second part of our presentation, I'll show you how to do this wiring through the clips and all that, and what are the new features in 2021. And what's happening is, this is the 3D CAD software. It also has the SolidWorks Electrical. So I can go ahead and open a project manager here and open any project I want. For example, let's look at this. This is the same electrical cabinet in 3D. I can see all the components, how they're going to fit inside the 3D assembly, right? So now we are talking with mechanical engineers. We can explain to them, this is the cabinet which we fit into our machine or something. And maybe there's a bigger mechanical assembly where we need to fit. For example, this electrical cabinet is going to go on the wall, right? So this is the full 3D model of this brewery. And these 3 tanks have some, heaters and electrical connectors, and the wires are supposed to come from this wall, go along these clips, hop over, and then connect to this. And I can lay out all of this information in 3D, right? So that becomes very much essential for modern machinery where you have limited space and you need to know where the wiring is going through. This becomes a very powerful tool. And for that, we just have a simple add-in of electrical. It shows up here on the left side. It's the same HOTD project I can open in there. In fact, I can even view some of the drawings in here. I cannot change them, but I can at least view. So on the mechanical side, the engineer can see what the wiring and connection is, or the technician. So this is a very powerful tool to have, definitely. So we have faster schematic creation with fewer errors. We can generate reports, we can reuse data, we can do rapid change management. It's very professional and accurate information, right? So we have intelligent tools, which is keeping the intelligence of all the parts. So tags, wire numbers, all of that is being kept by the software, and we can reuse them. Just a click of the button and you can generate drawings for the terminal strips, which are cumbersome, and all that. You can do copy paste. You can use these circuits in different drawings. You can keep them as macros and use them in different projects. And that makes the whole thing very professional documentation possible for bill of materials. And you have peace of mind that if you made any change, you're not going to make any errors. Software is there to take care of this process for you. Okay, so let's move on to that electrical 3D we were talking about. In the 3D routing in 2021, we have some new features, which I want to mention. So there is a routing through clips, which is very important and good feature. There's an improved harness design in which you just don't use lines, you can use splines, etc. If you have a cable with multi-conductor cables, like 7, 8 of them conductors, you can route them separately now in the 2021 version. And you have terminal strip managers and drawings. So let's start here. This is the drawing I was showing you. That's the wire which is going through the clips, and that is fine. But on the other side, this red and green wire are not going through the clips, right? So what you do is simply pick this wire. This is the one which has to go through this clip. I'm going to edit the route and go there and route through clip. And after that, once I have this feature selected, I'm going to go and pick which clip. So I pick the axis, click on the wire, and the software will do the rest. It will just route it through it. I can go there and change some of the parameters if I want, like offset from the clips. I can arrange it in millimeters or inches or whatever I want to do. There are lots of other things available in the software to arrange some parameters. Once you are done there, let's say if you want to do wiring through two clips at the same time, that's easy too. In 2021, you can click two clips at the same time and it will wire through both of them, right? So that becomes very easy, saves us time. Also, let's go on to 3D routing. You can have splices and lines in here. So this is the EW path, which tells you the route that cable is going to take, right? Let's focus on that. So let's take off the mechanical assembly. This green light is the path. Now we can use splines in here, so we can bend it, just the way we want. And once we are done with the EW path design, then we can just click on route harness. That's the electrical 3D and mechanical. And then we pick up, whatever the parameters, the routing parameters, what the difference, which harness, and we are done. So that is done. At the same time, we can even add splices. That was a feature from 2020, but has improved in 2021. On the schematic side, the schematic drawing is now connected to that. We can pick separation of routes for the same cable. So we have a connector. Cable number 2, W2, is coming through it, multiple conductors in here. But there's this separate route assembly, right? 3D routing. So we want to route different conductors in different ways, okay? So you just click on that one. And now we have two separate paths, these pink paths. So it's the same cable. We are splitting into two. And again, we are routing the cable. We are going to pick which ones. So 8 core are going through there. And there is a W3, the second one. They are going to be separately routed. Okay, so now this is done, right? So we have separate routing assembly going through that. Okay. Also, as I mentioned, the terminal strip drawings and terminal strips in particular are very problematic because they have lots of terminals and you have to keep a track of it. So we have a terminal strip manager which takes care of it. It will give you a graphical representation of everything. So this is a terminal strip drawing generated automatically. All you have to do is just connect your terminal strips and it's going to generate this drawing. Excuse me. And then there are different type of terminations which we can select from our library for these terminal strips. And then we can go into the details of this drawing. So we can customize this drawing whichever way we want to look, like different distances, different colors, different wire systems, cables. So everything is customizable. There is an SQL database in the backside, and we can play with a lot of parameters in here, which will make it's easier for you the way you want the software to work. So just to summarize, before I give it to Nick, is SolidWorks Electrical has spline lines and other entities in 3D routing, which is new. We have enhanced capability to arrange wires and cables, increased flexibility with flattening control, enhancement to PDF file generation. We have enhanced management of cables and wires coverings, et cetera, with enhancements of wires without end termination, and some Excel-based automation. So with this, any questions from the audience?
Great, thank you so much, Talal. And just right before we jump into the questions here, I just want to let everybody know if you'd like to see a document with a summary of those new enhancements in 2021, there is a data sheet available in the GoToWebinar panel right now. So you can go ahead and download that if you'd like, otherwise we can follow up with you afterwards. As Talal mentioned, we do want to take a couple of questions right now. I think we'll just take 2 or 3 right now to be mindful of the time so we can get through PCB after. But if there's more questions, we'll certainly address them at the end. So we do have a couple of questions here for you, Talal. So the first question that we've got is, do you have built-in libraries for electrical symbols, and can you show these?
Yeah, good question. Yeah, absolutely. Everybody needs those libraries. So here's the schematic. If you can see, there's a library tool. We have lots of different types of libraries. So first of all, we have a symbols manager. And if I click on that, you see all these different types of symbols in there. Excuse me. You have capacitors, connectors, etc., and we can directly use these ones, or you can make your own, right? So that's the symbols manager. Then we have the 2D footprints library. Again, you can assign any kind of symbols to these. They are organized pretty well in here. Fuses and disconnects. Then we have title block manager, and then we have manufacturer parts manager. In this one, you can filter out based on what kind of manufacturer we are dealing with here. For example, we can select Allen Bradley or Rockwell part or Phoenix contact, and you just click on the search, and it's going to bring in all the parts for that. Of course, you can select whatever you want to do and whatever the fields are for those libraries. We also have this cable reference manager. So manufacturers for the cables are listed here, different types. Or you can create your own cables, right? So these are all the libraries which are available. There's online contents as well. Okay, so you can go online. There's an electrical content portal. From there, you can download more parts and more symbols and manufacture parts. So that's another complete tool for that. All right.
Great.
Yes.
Perfect. Thank you, Talal. Now, Nick, I'm not sure if this question is better directed at you or Talal, but the question here is, we use SOLIDWORKS Premium and have cable and wire routing. Is that the same as what we just saw?
Okay, I can take this, but I think I'll need a little help from Talal on the back end here. That's actually a really great question, and the answer is no, not really. The specific sort of value of having the electrical 3D connection is that it actually connects the schematic environment to the mechanical environment. In that, when we have that 3D connection tool, we can actually read the schematic project, the origin to destination list, the from to list, right? That differs a little bit than what we have in the premium version. We do have automatic sort of routing capability in the premium version, but we're not pulling from a schematic project, right? So everything is sort of self-contained with that mechanical environment. There's still a lot of power and functionality there, but if there is a collaborative effort happening between EEs and MEs, then the work that's been done on the schematic project can be leveraged and utilized in the mechanical environment when it comes time for routing. Talal, I'm not sure if you want to add anything to that.
Yes, so there are two things you explained it pretty well, actually.
Thanks.
So there is a built-in routing feature in our SolidWorks, yes, right? So, but that is not connected to the SolidWorks schematic. So you can create your own wires and cables in there. That is fine. However, it's not going to be just like I was showing to you that there's a, on the right side, you see the electrical project and the cable information and component information is coming from my schematic drawing. That's not going to happen. What's happening here is I haven't turned this add-in on, but there's a routing add-in in your here, this routing add-in. And this one is for piping and tubing, as well as some electrical connection. So this is some basic rudimentary wiring capabilities, which is possible for you to do. Here you see the 3 of those tabs in here. The electrical connection is here. You can create your own wires, and then definitely you can do the wiring and cabling in 3D. But it's not going to be connected with your schematics. So you have to take care of it yourself.
Right.
Okay, great. Thank you both. I think we'll save the rest of the questions for the next Q&A period at the end. So let's go ahead and get into PCB.
Okay, so as Talal, if you don't mind, you can bring back up that presentation there.
Yes, please.
Perfect. So we're going to give Talal a little bit of time to move in between software packages here. And while he's doing that, for those of you who don't know, all right, SolidWorks PCB is the result of an Altium Designer and SolidWorks partnership. All right. A few years ago, Altium Designer decided to chase a bit of a higher market, right, in terms of their electronic capabilities. And in doing so, they understood that they were actually leaving a bit of a gap in the middle market in terms of PCB design. It was at that moment that SolidWorks sort of realized, hey, right, we have a lot of commonality between their users and ours, so there might be an opportunity here. They also realized that some of the functionality inside of Altium Designer simply was never relevant to many of our customers, okay? So with that understanding and this partnership in place, they were able to come up with a product that was more relevant to our market's workflows, right? Again, not sacrificing on power and functionality. And they were actually able to bring the price point of that product down, right? The initial cost of entry. So, driven by 50 years of Altium Designer technology, SolidWorks PCB now offers the same features and benefits that made Altium Designer initially so disruptive, right? Namely, their unified platform, being able to work within a single design environment. Talal, can you just move us over to the next slide there? Thank you. The other thing that was actually particularly disruptive with the introduction of SolidWorks PCB was the ability to bring the mechanical and electronics teams closer together, right? Gone are the days of siloed engineering disciplines. In today's day and age, electronic requirements are becoming more and more complex, right? Enclosure envelopes are shrinking, right? PCBs are becoming smaller, but need to be even more powerful than they were yesterday. So now, more so than ever, it's truly critical that mechanical and electronic teams can actually communicate bidirectionally in real time in order to accelerate that design process and ultimately innovate, right? And a lot of you guys on the call might be familiar with this if you're working with electronic and mechanical tools today, that traditionally electronic teams share board information through IGES and step files, right? The problem here, though, is that we can't share important board and component information, right? How are we going to check that our mounting holes and our board cutouts line up, right? These are all really relevant and important questions. So, I guess the good news here again is that we have a solution to address all that. And that's what this next segment is hopefully going to address. So again, without further ado, I'm just going to go ahead and pass the mic off to Talal, and he's going to get us started with that presentation. Talal?
Thank you, Nick. Yes, so the outline of this portion of the talk is something like this. I'm again going to give you a little bit of brief overview of SolidWorks PCB. What are the features? It's basically based on Altium engine, as was mentioned before, and it has a schematic and PCB design capabilities. So we'll go over some of those features for you who haven't seen that before. But the main thrust of my talk is going to be on these 2 points: ECAD, MCAD collaboration, which is very unique feature for our SolidWorks PCB product, and how it works. And definitely the new one feature which is coming up in the market as well is rigid flex board design, right? And after that, again, we are going to take some question and answers. So going into this schematic design, and just to show you some basic capabilities of it, let me just move out of here. And this my SolidWorks PCB over to here. Okay, so let's close this document. So this is SolidWorks PCB, as you can see. I have a couple of projects open. Let's just focus on this one. These are the schematics, as everybody knows. Schematics can be multiple sheets, and in our software, we have like 9 schematics in this project. It's a hierarchical system in which you have this top level sheet controlling all the others, and the connections are going there. And then inside this, you have different components you can place and wire together. So again, we have a very powerful library in here, which is built into it. It is both for symbols, for schematics, as well as the footprints for 3D, right? What is unique about our system is since we have both solution, we have an integrated library solution. On the left side, you will see that we have a PCB library document and you have the schematic documents. And what we have done is if you have any one of these features, and let's check the properties of it, well, there is a footprint associated with it. So we have, just a schematic symbol, but we already know what kind of a package this SSOP16 package we are going to assign to it, so that once we finish our schematic design and we go into our PCB module, we will have all the footprints ready. And this is what is schematic design for this project leads into. This is the PCB board for this product. So we have different components already placed, routed, and assembled together. We have a very easy to use user interface on the top. And this user interface changes when I switch between the schematics and PCB. So for example, I'm in this PCB view, and right now I have all the things I need for PCB design, like pads, vias, lines, arcs, etc. The moment I switch back to schematic view, this thing changes, because what I will need in here is placements of parts, wires, net labels, etc., etc. So there is a built-in intelligence into this tool as well, which makes it quite unique. However, the most important thing we want to mention in this talk is when we go from a schematic to PCB, what we have is this SOLIDWORKS PCB connector. This is the connector which connects between SOLIDWORKS 3D and SOLIDWORKS PCB. For example, if I want to send this board over into my mechanical design, and we'll go into a little bit more detail of that, this is what it's going to look like. So it's going to bring in the whole board, all the components and stuff like that using that connector, and we are going to see a demo for that. Why do we need it? Good question. Well, what's happening is this. We are moving, sorry, just a second. Let's go down to, I think I have opened two of them. That's what's causing confusion. Sorry about that. Okay. So, for example, this is a real prototype of an actual product, right? So this is a model. It's a robotic arm. And let's take off these top covers from this. So I'm just going to suppress those guys. This is in SolidWorks CAD 3D. And what you are seeing right now is that PCB board is neatly fitted inside. Long gone are the days that we used to have a rectangular board. The board shapes are quite complicated, okay? Those board shapes need to fit into very tight spaces like this. They have to connect to other things. There's the battery on top, which is this connector is connecting to. Let's take off this cover and you will see that there are connectors on each side, and those connectors need to be placed properly. And there's not much headroom in there. Like everything needs to fit in 3D. Let's measure this. How much is the distance clearance we have from this mechanical plate? So let's measure this line from this metal part, and 0.552 millimeter, like half a millimeter. So that kind of clearance we are dealing with in here in PCB design. And then the connectors need to be placed so accurately that they fit with other mechanical bodies. Like we have this battery, and our PCB board, we cannot just place this connector anywhere. We need to place it where the battery is going to be, right? So mechanical engineer has designed the battery location, and the electrical engineer now needs to take care of it. So if I measure the distance from my connector to the battery is 0.225, sub-millimeter precision required in that. So not only my board shape is complicated now, it's not rectangular and I need to make it more accurately, and my components need to be placed more accurately now. So let's talk about that. How can we do that? If I go back to my PCB, well, this is Altium-based engine. It's one of the best in the market. But if you go into the board shape outline and defining it, it can only deal with just simple rectangular shapes, some edges and things like that. It doesn't have the capability to really design. Whereas if I switch into SolidWorks, and if I go into the sketching part of it, it has versatile tools, very powerful, because this is for mechanical engineers who are making really complicated mechanical shapes. So they need some very powerful tool. By making the connection between my SolidWorks PCB and this SolidWorks CAD, I can utilize all these features for my board design. And that makes it very valuable. And that PCB connector is just simply just like my electrical connection. It's on the right side, and I can just pull the board from a project and make it work in this environment. And let's see how it works. So going back to my presentation mode, let's see what we do in this whole process. It's not so complicated as you might think. Actually, it's pretty simple. Let's just add a blank PCB board to my SolidWorks PCB. And it comes with a basic square rectangular shape. Okay, that's fine. We don't need to deal with it anymore, because what we are going to do is we are going to commit this project, save all the files, and actually send the board over to the mechanical side. And then we'll ask our mechanical engineer to take care of the board shape depending on his design. We can also do it ourselves. It's not very complicated to design the board shapes there. So let's save the files. And once the project is committed, that's the version control built into our software. All we have to do is push the board, very simple, built-in tool, write a simple note. I'm pushing this board over to the mechanical side. And what happens is, once I post it, it goes to an intermediate software, which is called SolidWorks PCB Services. That can be located on a server. So the electrical and mechanical engineers could be sitting in 2 different countries. That's fine. And now the mechanical engineer goes and logs into this server. In my case, it's a local host, so it's my own computer, right? And he has his own login name. And it will show you all the projects which are available on that server, PCB services, right? And I'm going to pull that board. I'll pick which project I want to work on. So I'll pick this board and see what is there. And this is now pulling the board. Now look, the file is coming in SLDASM format, which is the native assembly format for SolidWorks. So I'm not losing any information. If I converted that board into a step file, then it's just a piece, one single piece. Okay, just for the plain board, that's okay. But if you already have so many components, you will lose all that information in this exchange, right? So conversion to a step file is not a good thing. Now, when I come back here, the board is here, and it has converted it into an assembly. I'll save that and bring it into my main assembly. So let's switch over. This is my assembly, and I'm going to go and insert a component. So this sub-assembly of my board, I'm just going to drag and drop it somewhere here. Not very particular at this point. In this software, SolidWorks CAD, I have powerful tools to mate, position, very easily all these things, right? This is not available to me in my PCB software, but here I can use all this. So I'm going to mate that board to this surface. That's where it's going to be located. As I said, I need precision in placement of the board. We are talking about sub-millimeter precision, so everything has to be precise. The board location needs to be exactly where it is. And then I have this sketch utility, as I showed you before. Let's say the mechanical engineer has already created a sketch for me, what that board shape is going to be based on the underlying mechanical equipment they have. So I go into this board outline part. There is this sketch. I can open that sketch. Right now it's just a simple rectangular shape. I'm going to just select it and delete that. I don't need that. I need the other sketch. I'll just click on Convert Entities, pick up that sketch from my list, and that's it. My board shape has changed. I'll save it, rebuild it, and I have a green board with complete mechanical shape in here. So that is much simpler to do. If you tried making this shape in Altium or SolidWorks PCB itself, or most of the other software, it will take you hours just to get every precision here. But here we are, within 5 minutes, I've been able to change the shape of the board. Now, after saving it, I can send it back to the PCB. So I'm going to post some message that board is finished. I've done the outline. So send it back. It goes again to the PCB services. I can log off. Next day, the electrical engineer comes. He opens the board. This is still the old one. Oh, I have it changes. I have new board shape. Okay, I'll accept the changes in here, and I have new board. Okay, so very simple to do, and I'm just gonna commit this project, save it, and then check it in 3D. What does it look like? What the board shape is. And it has preserved all the information. I didn't lose any layer information, any board stack information, nothing. It's both softwares are SolidWorks, so they're talking to each other without any hitch. Okay, so now let's go to component placement. How difficult is that? Well, again, it becomes more important to use such a tool. I need to place the component from the PCB side because the electrical designer is going to pick which connector he wants for his thing, right? So I go again here. I import changes from my schematic. Right now, I just want to place one connector. So I disable everything. I'm looking for J2. That's the connector which was going into the battery, right? So I pick this, validate, execute changes, bring it, and I drag and drop. Now, this is what we are used to doing. We can rotate it. This is PCB. I have 1 degree precision in here, but it's very hard to place. I know I have grid lines, but that's basically it. I have no idea what's going on with the rest of the mechanical assembly, right? So better to send it over to the mechanical guy. Again, I'm going to commit and save it. I have placed the connector. Let the mechanical engineer place it exactly according to the rest of the mechanical design, and then send it back to me. So I'm posting it. Now the whole 3D part, if I did the step file, it will lose all the information, the footprint, everything else. It will go into mechanical, but then when I bring it back, I have nothing left, right? So in this way, all these layers, you see so many changes in here. It's not just one connector because it has overlay and top layer and bottom layer and copper layers and signal layers, ground layers, everything coming in, right? It has all the information which was from the PCB. And we are not going to change that because we are going to send it back later on. So now the software is bringing in that 3D design through the PCB services. Right now I have both softwares open, so it's looking. It has drilled the holes where this is going to go through and mount on the board. And I can see it in 3D. This whole connector has come. Now, I have a couple of things available. Roughly speaking, I can place it using this triad method. In my 3D, I can do XY movement if I want to do. But for real 3D precision, what I need to do is I need to put it in the bigger assembly. And first, I need to put it on the other side. So I'm going to flip it to the back side. The software is going to do it for me. I just click a button. You see the mounting holes changed for that one. I'll save it and then bring it into my main assembly. And here's my connector. Now I can drag and drop in there. Let me fix my battery. Your battery is fixed. And what is going to move is the connector in relation to that. So I'm going to drag it somewhere right or left. And now I can use precision tools in here. I'll use the mate. There's a very special mate. There are lots of things available in here, coincident, parallel, but I'll use advanced mate, which is called width. And what I just have to do is select the 2 faces of my connector and then the 2 faces of the battery compartment and tell it to automatically center it for me. And since I already had some other mates before, it's going to break that. I've told it to break that one. It gave me a warning. That's fine. I don't need those mates. This is more important right now. So I'm going to go and delete that mate. I can change it to remove it, or I can just simply delete it. So at this point, I just don't need that mate. So I took it out. So now the connector is perfectly placed. In a couple of clicks, I don't need to measure anything. I need to align anything. SolidWorks CAD mechanical is so powerful that it has all these built-in capabilities. And as a PCB designer, I can use all of that to my advantage, right? And save my time. So all the critical components can be sent over to the mechanical people, and they are going to place it. And once they have placed it, they can fix it, right? And then please don't move it. We can fix it in the mechanical side or the electrical side. Let me show you how it is done. So on the mechanical side, we sent it. On the electrical, we see the changes. The component has been placed. You can see it was flipped on the other side. And now I can go into my properties, and there is the locked button. So I'll click it on. There you go. Okay, so now nobody should move this, right? So that's the critical component. I have precisely placed it. And then I can continue with my design with the rest of it. So that is what the power of this collaboration tool is. Like, talking between electrical and mechanical becomes so important at that point, that it is so easy. Instead of turning it into IGS file or step files, you keep all the information. There is no translation between the files. Both are SolidWorks product softwares, so they understand each other, they talk to each other. Now, going to the rigid flex design, that's the next level where everybody is moving in the industry. That, you know, the connections between different boards used to be taken care of by the wire connectors. But there is a limitation. When you have a 32 level board and you want to use connectors, how do you do that? There is just limited space on it. So what they have come up with is flexible boards, right? Instead of regular wire connectors, they are using these flexible portions as a connector in between two rigid boards. And we do have a capability to design such a system in here. And that's what we want to show in here. Again, to starting point is just a blank board. We are gonna check the stack manager. We fix which is the flex part of it, what is the rigid part of it. Basically have our stacks ready to go, saved, and sent over to the mechanical. This is pretty much the same assembly. This is the push button side of it, the user interface for that robotic arm. And we have integration with the PDM as well, by the way. That's a separate issue. We can talk about that later. So there are two version controls within the software. One is PDM, mechanical guys love to use that one. And PCB has its own version control, plus it integrates with the PDM as well, right? So I pull the board here, and now this is the blank board. I'm just gonna drag and drop in the main assembly as I was doing for the other things. And I'm gonna, again, you know, the shape is not right. It has to be that long rectangular shape. It has to fit that. So I'm gonna go and change the sketch of it, edit the sketch. And as I did before, take off the rectangular and use the geometry behind me to turn it into a long shape exactly precisely as I want it to be. Okay, so that's the publish envelope. So that's my new board design. And there is that connector, the light blue, where I need to do. Now, I need to design my flex portion, the so-called connector portion of it. So the rigid part is your regular board. And I can use all the design capabilities and SolidWorks CAD, quickly design this thing and change my board shape, and here is it. And even here, I can define what is the flex portion and what is the rigid portion. I can do it from mechanical side as well. That's allowed, right? But I send it over to the PCB side. You decide what you want to do with it, please. Define the flex region and the buttons and everything else. So I'm going to push it over there. And then it comes, we'll see the changes in the board shape. Yes, that's great. And then we are gonna define the split between the rigid portion and the flex portion. So that blue line is the division. So this is the rigid portion, it's locked 3D, and this is the flex portion, okay? That's the one which is gonna bend. Also where it is gonna bend along. So 2 axes, I'm defining 2 yellow lines. That's where the bending is gonna occur, okay? So when we see that process coming in here, I'm sending it back to mechanical. So I'm just skipping a couple of parts in there. We have limited time. And we accept the changes. It brings in all the information of flex region, and that you can see the bending of that flex region, right? It turns into, so 2 bending axes I put in there. I can change the appearance, make it look yellow, just so that to differentiate from the other side of the board. And then I'm gonna mate it, and then I can play with it as much as I want to do. There are lots of capabilities here on the mechanical side. That's the connector I'm trying to connect to. So I need to change the board outline, shape, width, size. Much easier to do here if I want to edit, right? In the 3D environment. I can change the angle, flip it to the other side. Then again, I have some rough capability of bending it over and some precise capability. For the time being, I'm using the distance between these two, change it to, let's say, 8mm or whatever. And I can adjust the dimensions of any portions, give it relationships so that it remains there. Okay, looks good. Now I want to bend that, so I can bend it, sorry. Okay, like this, fold it almost onto itself. It has to neatly fit into that small space behind this board, right? So now I can see it is fitting, it is clear, but the length is too much. It is still missing the connector. Okay, fine. So adjust a few more things, drag it down, and now I'm done. Okay, so it's going into that connector. And that's basically it. So that's a flex rigid design in SolidWorks, PCB and SolidWorks CAD. Okay, so in conclusion, we have an integrated solution. It is a schematic design and PCB design both in one, based on Altium engine, a lot of capabilities there. We showed you some ECAD, MCAD collaboration capabilities, which is not available in other softwares, right? So that makes it so powerful. We have a versatile PCB board design, high precision component placement, complex shaped board cutouts, and that is all happening because of this ECAD MCAD collaboration, right? Seamless transfer between PCB and mechanical which is allowing us to go between the two. With that, let me hand over to Nick. Sorry, I'm running out a bit too long. Questions?
Great, thank you so much, Talal. We are about at time, but we're still good over here. So I know there were a few questions in the queue that we do want to get to. So feel free to hang on with us if you've got any questions for Nick or Talal. So Talal, the first question we have for you here on PCB is, can you use step files as 3D bodies, or is SolidWorks parts file better for it?
Step files are okay. You can use it. If you have already designed step files are okay. However, step files do not contain all the 3D information which SolidWorks SLD part or SLD assembly files have. So it's better to use SLD parts for your 3D bodies, especially if you're going to do a collaboration between SolidWorks PCB and SolidWorks mechanical. I would highly prefer to use SolidWorks parts instead of a step. Yes.
Okay. Great, thank you, Talal. Another question for you here on the PCB topic. Can you bring in data from supplier links into SolidWorks PCB?
Oh yeah, absolutely. We have a very good capability. So let me just very quickly show you. I mean, I know I'm out of time. I can talk about this for hours. So in the system preferences, we can see that if you go into PCB editor, a general setting, there are supplier links that we can link to, okay? In the data management, what kind of version control and this. So here is the suppliers links. Let me just click on this guy. And this is around the world, all the suppliers databases which we are linked to. It's not just one or two, there's a long list of suppliers. And how do you use that? Well, if you go into here, there's the suppliers button. And let's say I want to search for ESP32, right? This is a microchip, very famous. A lot of people like to use it because it has, wireless capabilities. That's a Chinese-made one. And here you have a list of all the supplier: Time, Allied, Mauser. Mauser is obviously very famous, and DG and all that. It has the description. It even has pricing, whoever has placed it in the web. So it goes through and searches that. Or we can have, just resistor, 10K. Okay, fine. Let's go with that. So 10K ohm resistance, what do you need? Well, what are the prices? Who is giving it? What does it look like? What's the package, right? All that information is imported. I can select all this information and transfer it to my part. I don't need to retype all of this. So this is what we call supplier search and supplier link. And I can do all this directly on my schematic in here. And any part I have in here has properties. So these are brought in from the supplier. So supplier is Farnell for this one, and all the package and information. Good. Yes.
Okay, great. Thank you, Talal. And just one more question for you. This one came through on the electrical side. The question is, can you add a restraint for wire routing minimum radius depending on the wire type?
Yes. So when you are defining the wires in electrical, sorry, I've closed electrical. I can turn it back on. So there is a adjustment on the electrical side which deals with the bend radius of our system. And let it open up in time, then I'll show you. Just 1 second. So let's just open any project. Let's just say this one, right? That's fine. So in here, when you go into the project configuration, there's a wire style manager. And that's all the list of wires we have generated, which we want to use. And each of the wire, there are properties. And we can adjust whatever we want to do. And there is the bend radius factor and bend radius, diameter of the wire, the gauge, 14 gauge AWG system if we are using and stuff like that. So all that information can be incorporated in here. And when we take it to 3D, we can define how much is the bend radius and how much we want to use it. And there are lots of other things, obviously dielectric type, voltage, current, frequency, stuff like that. So lots of parameters we can adjust for the wires if we need to. Yes.
Great, thank you very much. All right, I think we're about 5 minutes over, so I think we will have to cut it off here. But for anybody whose question we didn't get to, we'll certainly follow up with you afterwards to get you those answers. And if you think of anything after the fact for us, you can certainly reach out and we'll put you in touch with Nick and Talal to get you answers to those questions. Nick, Talal, any final words before we end off here?
From my side, sorry, Nick, but yeah, just talk to Nick. I'm happy to give a demo to you guys. Anything you are interested, we can do a personalized demo and we can answer all the questions. I know I didn't have enough time to explain 2 softwares in 1 hour. That's impossible.
It's definitely ambitious, and to kind of echo what Talal said there, I obviously want to thank everybody for taking the time out of their schedules to join us today. If any of this is worth further investigation, there are a number of different ways that we can help you guys out, whether it be a trial of SolidWorks Electrical, a trial of SolidWorks PCB, a hands-on test drive where someone like Talal will actually guide you through the design process and workflow, and obviously a specific demo as it would pertain to your specific application and workflow. So with that said, don't hesitate to reach out to myself or Talal or your respective account manager. We're here to help you guys, and we're here to help you with any evaluations that you guys might have in mind. Okay, and with that, thanks.
Perfect. Thanks very much. Thank you, Nick and Talal, for a great presentation. Thank you to all of our attendees for spending a little bit of your Tuesday here with us. We certainly hope to see you at some of our other sessions throughout the remainder of the week. And don't forget to keep an eye out for that survey for a chance to win some cool prizes. All right. Thanks a lot. Take care, and we'll hopefully see you soon.
Thanks, guys.